了。对啊，还跨年夜叫我这边做实验，还没有年终奖金，忙什么忙啊？哦，哎，快看了！哇 ，wonderful！ 哦，你是怎么做到的啊？
OET 旋转的啊。
People record the surface of the Earth by rotating the satellite equipped with camera to film the appearance of the car. We walk around it with a camera. But what about shooting a cell? If we surround the cell with a microscope to record its topography, it would be complicated and impossible. Contrary, fixing the camera but rotating the cell is more suitable.
The fundamental configuration of optoelectronic tweezers, OET, can be used to rotate cells. The configuration contains a microscopic image capture system, an OET chip, and a projector. The OET chip is composed of two ITO glass plates, which sandwich a layer of media containing cells. The lower glass plate is coated with a layer of amorphous silicon, which is used as the photosensitive layer. During manipulation, the ITO glass plates are subjected with a driving voltage. Then, a light is projected onto the lower glass plate. When the amorphous silicon is lighted, its resistance decreases and the electric field in the media above the lighted area changes. Traditional OETs are only used to move cells linearly. Professor Ye's research uses OETs to rotate cells. How does it work? Let's take a look at the equivalent circuit. In the area nearby the light projection boundary, the OET device can be modeled as two parallel capacitors. Each capacitor is in series with a resistor. The lighted amorphous silicon has low resistance, whereas the unlighted one has high resistance. The two capacitors have voltages that have different amplitudes, the same frequency, and a phase difference, which induces a rotating electric field. The research team used the software COMSO to simulate the case. As the slide shows, a rotating electric field exists in the area nearby the light projection boundary. In the area away from the boundary, the fields only change the amplitudes along one direction. When the light boundary is near a cell, a rotating electric field is induced, hence rotating the cell. Using this method, the team can rotate a lot of cells simultaneously. They can also use OET to trap a cell in a well, then use the new mechanism to rotate the cell. Applying this method, it is easier and more effective to record the surface of a cell.
Tissue engineering is central to many new efforts to mitigate effects of foreign organs. If people someday want to use an artificial means to assemble an organ, scientists have to understand how to mimic how that organ's tissue is put together, and cell manipulation is the key way to achieve that objective.